And okay, y'all. It looks like my audio's coming through.
You can hear me?
Yep. Can you hear me?
Or-
Bet. All right. Um, let me just post this. Okay. Okay. So with this one, um, so what we're gonna try to do is Ethernaut's hard hat. Not hard hat, but Ethernaut's level 12. Um, just for reference, these little dots represent like how hard a challenge is. Um, and we're at privacy, which is a really tough challenge. So
Hold on,
I'm
your screen's not loading. Give me 1 second.
okay.
I can't
Um,
see what you're talking about. I don't
okay,
know why it's not loading. Let me back out.
okay.
Let's see.
Make sure we're good on YouTube. I think YouTube can see. Yes, okay. So the stream is loading on here. I don't know if it's loading on Discord.
And nah, I can't see it. I don't know why it's not loading.
Here, let me try it one more time. Share screen, screen one. All right, what about now?
Uh,
Yeah, should be good now. Yeah, it should be up now. If not, go to here. Go to this YouTube right here, and then just uh mute the YouTube channel so that we don't get double feedback. And you should see my stream on there.
let me see. Oh no, I see it now. It's loading, so
Okay,
we're good.
perfect, perfect. All right, so in our last challenge we did elevator, and I'll briefly walk through that real quick. So, how elevator worked was there was a floor we needed to get to, and if we called this with a regular externally owned account, we wouldn't be able to necessarily get to that floor. And the reason for that is because it was expecting an interface call to a contract. So how I exploited this is I created my own contract called attack, and was basically able to create my own is last floor that did something wonky, which allowed me to successfully complete the challenge. So what we're going to do now is look at a challenge called, let me bring it up, privacy. It's a pretty tough challenge, and I can tell you right now, I'm probably not going to be able to finish this in this session, but we're going to just walk through my process of how I approach this problem. And if I have to cheat, then I'll show you my process of how I look at write-ups and the whole nine. So I have everything on GitHub, and I'm gonna create a new branch for uh, specifically for this problem. So check out privacy. Okay, and we have to do a few things to set up this attack. So uh, let's first let me move this to here. We're gonna bring in this code, and I'm gonna rename this to privacy. Also gonna rename this, and I'm also going to not import elevator and just comment this all out because I really don't know if I need this right now. Um, we have an attack template, and then we have local. So first things first, as an attacker, you typically want to do things locally before you run your attack live. So I have a setup where I do everything locally, and then I have a setup where I do everything live. It's on testnet on Sepolia. So let's take a look at a few things, as well as initializing this contract. Actually, you know what? I don't need to initialize it yet because I want to do everything locally first. So we have this contract here. So let's take a look at this and then also what we need to do. So the creator of this contract was careful enough to protect the sensitive area of its storage. Unlock this contract to beat the level. Things that might help. We have understanding how storage works, understanding how parameter parsing works, and understanding how casting works. So I know a bit about storage, a little bit about casting, a little bit about parameter parsing. Um, Remember that MetaMask is just a commodity. Use another tool if presenting problems. So for those of you who are reading this, what this means is a lot of folks have been using the console up and for a good portion of um, these challenges, but you may want to use something called Remix, which is where you could deploy code a little bit easier and also read like contract state a little bit easier. And another thing you could do, which is what I'm doing now, is I'm doing everything locally on my machine using Hardhat and Solidity. So, okay. So the idea is we want to reveal some sensitive information to unlock this contract. Just as an auditor, like I'm just going to run through it. So we're good with this up here. We have contract privacy. We have the contract starts off as locked. And I want to just go ahead and say that this is 1 byte. So that's going to be in slot 1 or slot 0. We have a uint 256. It's grabbing the timestamp. That's interesting. Do we use this timestamp? No, I don't see any other use of this. So I don't think this is really important to the vulnerability. But I see it is important because we have to get some private information. So for anyone who's jumping in straight to this challenge, there's public data and there's private data. Public data has a getter function already automatically included. So let's say I wanted to retrieve this value. I would just call, for example, privacy contract dot get locked value, and it's going to return true. Now, if I did privacy contract dot get awkwardness, we wouldn't be able to get this because it's private. But the caveat to this is because it's on a blockchain, we have access to this information. It's just not an easy getter for it. So we can grab the like bytecode level, which would look like some crazy stuff like this. We can grab the bytecode level, right, and get that data from directly from the chain and see what this data is. And that's kind of how this attack is supposed to work. We need to grab unlock key. Where's the key? Bytes. Key is equal to byte 16 data at slot 1 at 2. So, okay. So basically we have to figure out where in the storage slot does this fall, and then we have to find out where in the storage slot data is equal to data. Oh, we have to figure out. So basically when they initialize the contract, they're going to pass in an array of bytes 32. So it might look something like it may look like password data. It may look like false correct password, and then password data. right? And they're going to pass in this, and we have to be able to visualize where the second one falls. Or no, no, no. This is at 2, so it's here. Yeah. Yeah. So it will be this. This will be the correct password. And what we got to do is, ooh, this is going to be tough. So we have to figure out where, first off, what slot this is on. And then once we figure out the slot, there's going to be it's going to be a bunch of data that's going to look something like this. We have to parse out where in that slot does this one fall. So we have to be able to parse it and say, like, it's this chunk right here. And then we have to grab that chunk and pass that in to unlock to successfully complete this challenge. And I'll let you know now, I do not know how to grab that information. So we're just going to go from scratch and just take it step by step, like how an attacker would approach this. So we know this here. And also, Jay, if you want to chime in or have questions, like you're definitely free to come off mute and talk, so that people can see like how people collaborate, talk through
I,
stuff, ask
I
questions.
actually have to head out right now. I have to
Okay,
head to work.
all good.
So
Good
I will catch
chatting with
you.
you.
Great chatting with you. I'll catch you in the next one.
Cool, man. Have a good one.
You too, man.
All right, bye bye. All right, so okay. So I'm gonna go to like maybe I should go to 1:30 because I have to head out at 2. So let's just do the first part of this challenge, which for me is gonna be figure out what storage slot this falls on. So we're gonna go. This is at slot 0. This is gonna be 32 bytes. So this is gonna fall at slot 1, I believe. This is a uint8. That is, I think it's 1 byte. I should probably read through this for sure. This will be my homework. Yeah. It was 1 byte. Yeah, I think it's 1 byte. Yes. Okay. Oh, this has a chart. I wish I could just have this like in a chart format. If anybody has like a nice breakdown model of um, solidity types and byte size. Please. Nah. All right. I should be on. I need to go to. Okay. So I'm pretty sure it's 1 now. Well, actually, I'm not pretty sure, but that's my guesstimate. So 1 byte. This is going to be in slot 2 since the slot that's taken up. That's taken up. Yeah, slot 2. Um, 1 byte. Slot 2. That's because these are 32 bytes. Remember, a slot is 32, so as long as we can fit those in, those are compact together. Unit 16 is, I believe that's 2 bytes. Slot 2. So now it's got 4 bytes in here. So this is going to be slot 3. Oh, wait. No, I see. So let's say bytes at 0. Yeah. Bytes at 0 is going to be slot 3. Bytes at 4. Oops, what am I doing? Bytes at 1 is going to be, shoot, I'm messing up, man. Slot 4. Bytes at 2. You finished? Oh. Okay. Well, y'all, we may be ending the stream early. Oh, it's 1:30. Actually, that's when I'm gonna go. Yeah, we're gonna head out and enjoy some of Cali, Colombia. So, um, let me finish my train of thought, and then we'll be good. Slot 2, slot 3. Yeah. So it's 3 slots, and this made it easier because it's an array of bytes 32. Um, if this was something else, I would have probably been a little confused on how it's stored, but since it's byte 32, I'm pretty sure it's the first index is here, second index is here, third index is here. Space of 3, and then byte 16 data at 2. 0, 1, 2. So we're really grabbing the 5th slot. So in this challenge, to unlock, we need to grab the data in the 5th slot. And cast it. To unlock, we need to grab the data in the 5th slot and cast it to bytes 16. And this is where that is won't it cut off? Won't it like cut off some of the data that we need? But huh. Hey, I think I know where, at least where to go, which At first, it was looking like, okay, I don't know how I'm gonna be able to solve this right now, but I think that's the route to take. Let me go ahead and do local, and I want to set it for attack locally. I don't really need this right now, this setup. Um, let's try to do this. Let's try to just write in pseudocode what. Oh, no, 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 no. We need that. That's the setup. I don't need this one. And then we're going to perform exploit. And let's go ahead and just write out our steps. So call attack. No, no, no. Do I even need a I don't even think I need a contract for this. I think I can do this all with an externally owned account, honestly. Um, but it would be nice to create a contract that can also do the same thing. That would be a good learning lesson that I might end up doing later. So call to uh, use ethers JS to get storage slot at 5. Cast bytes 32 data to bytes 16. And save as key variable. Cast bytes 32 key data to byte 16. And then the last thing we're going to do is call unlock passing in the bytes 16 key. And that should be the vulnerability. Yeah. So I have to go, guys. This is really, really good walking through this and like breaking it down in bite size, because at first it was looking massive, looking intimidating, especially when you have these 4 bubbles that shows it's a pretty tough one. So yeah, I'm gonna go ahead and end the stream there. This is part 1. I'll change the title, and we'll focus on part 2 in another stream. Thanks y'all for tuning in, and have a good one.